unbalanced. In one case unbalanced. That is a good thing whether is the model stable or not. That is important. Okay? So okay. If I'm going to do this right, which is group? This is what group one, group two. This is a truss or a beam model. Truss model. So if a truss model can be a circular or not? Because we said what truss is no member, there's no bending at the end. So confirm it cannot take a circular shape. Okay? But does it make a difference? I want to ask, does it make a difference if I do this? Will the result change significantly if I do this? As a straight. Does it change significantly? Will it change significantly? It will change significantly or not? Yes. Answer is no, it will not change significantly. Because no, it's okay, but this is okay. No, this is perfectly fine. Okay, because this is a bending load, correct? So imagine if this is a bending load, where is the major bending stress coming from? Here and here. The top and bottom chord, correct? Inside here we're taking tensile load. Okay? There's a good point just now on the stability. Okay? This part is not going to be stable, not just because it as a circular. Because this part, imagine if it's rotational, right? It's not going to be stable. Here it will just buckle in. You need something like probably something like this, You need something like probably something like this. Then it will be stable as a truss. Okay? You need probably something like this, yeah. Can? Okay, and you probably don't need something like this. You don't need. Okay, it could be just something like this. Because like I say, if the question, if I'm going to do it as a truss, where is the most critical section? This and this. Here, not going to be significant. It's outside of our design scope anyway. Okay? Next group. Who is this group? So this is the beam or truss? Truss. A good question here, boundary condition. I saw that you know, hey, this is a very good effort. If you see here, compared to this, why? Because if it's a beam or truss model, right, the boundary condition can only apply at the node. It will only be applied at the node. At this node, at this node, at this node. Okay? But you put there BC, that means it's restrained vertically or laterally.
Vertically, horizontal.
Okay, so if what? Can you draw your this is all the question you think about this. All these questions you're going to ask yourself when you're doing your own model. Good. But are you applying a lateral load? Are you applying a lateral load to it?
Yes.
Then will you need to have a lateral restraint? Very good question. Now you start to think about it. Class, can you say what? I ask the question, can you reply that? Why will you not add a lateral restraint? Why not? Tell me. Quickly. Louder. Because it's turning. Because in the con rod, right, is the bottom allowed to move? Yes or no?
Yes.
But will you restrain it? No. But then you need to account for this eccentricity load, correct? Yes? Yes? Okay? If you account this eccentricity horizontal load, if you put it like this, it's not going to run. It's going to be unstable. Okay? You have an external move, you have an external body force, don't run away, you have external body force. You don't have an external restraint. Is it going to be stable? Yes or no? No, right? Okay, it's not going to be stable. You need the external restraint for sure. Okay? Does it make sense? Yes or no? Does it make sense? Do I do this? Just now your question was, does it make sense? Because the con rod at the bottom is free to roll it within the chamber, correct? But why do I say that you need to do that? It doesn't matter because I am just being conservative. I just want to find out what is the maximum stress at that point. Okay, most of the time, inside your inside your design space, right? When you do design this sort of thing, right? Always know that chances is the more restraint you give it, the higher will be the stress. Okay, imagine let's think about it. Let's say for example. Yeah, okay, never mind. Just this side, just this to corner one. Okay, let's say for example the core rod is free to rotate. I know that it's not fully restrained at the bottom, but I want to know whether this is stiff enough to take like a horizontal load or not. If I restrain it, the stress will be the maximum. Agree? Yes, agree? 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 Okay? So that's why I will restrain it. Make sense? Next question. Come. I said don't run away. Just now I asked the next question, right? So where is going to be the horizontal restraint? Mark, quickly.
All 3 points.
Yeah. Class, will you know in the hoist model, we only restrain one end, the other end is free to move, correct?
Yeah.
What about here? Am I restraining the horizontal restraint in all 3 points? Yes or no?
Yes.
Okay, yes. Answer is yes, Yeah. Okay, thank you. Which one? This one. Which group is this? Group 5. Come. Quickly. Hey, don't waste. I thought that I feel that this is helpful for you all. If not, I don't know how you're going to proceed. No, seriously. Okay. What is the problem with this model? Other than too small. Same thing as your assignment. I put that blatantly. Too small. Can you read or not? You all cannot read. I also cannot read. So if your assignment, your scan, I cannot read. Means I will point out. I cannot read. Whatever I can't read, I can't mark. Okay. So what is the problem with this? That's one. Secondly is, do you need this? If you're going to create a beam model or a truss model with this, like this complexity, right? You can't do that, right? So we're going to do this. You know, just like what we say here, we're going to do something like this. Correct? We just simplify it as a beam and truss. So we don't need this part. But I need to extend it. The problem is I need to extend it to the middle of the board. That is for sure. Because I want to preserve the moment up. Right, so I need to extend this up like this. Okay? Then restraint. Where is the restraint? Mark. No. Okay.
Here.
Okay, never mind. You take your time, you change the model first. I go to the next one. Who is this one? You all can change. Group 6. What is group 6? Group 6. Change. Yeah. Hey class, he said he don't know how to change. What do you think need to change for this one? Huh? The one? The top size is what? Other than the thickness, no one. Other than the thickness, what else do you change? Can you do this as a beam and truss in your averages or not? Can you do that or not? Why not? Just not what we say. Huh? Not just that. Can you model this as a truss section? Hello. Can you model this as a truss model or not? Why not? You shake your head, why not? Quickly, hey, hello. So you need agree, it needs to be like this, correct? Other than that, the pin joint, yes, but before that, truss. Is this a truss structure? Why not? Good. Other than that, geometry. Is this going to be stable as a truss structure? Why not? Why not?
No bracing.
Huh? No bracing, who said that? Come and draw. Quickly. How will you draw? No, I want you all to think about it. I want you all, because if not, when you run, right, you will keep complaining it doesn't converge, it's not stable, then what's going to happen? You all need to understand, you all need to appreciate this. Quickly. Yes, correct. One, for the truss to work right, you need a tie back, correct? You need a tension. In the recording we say, right, you have a top chord, bottom chord, that's the truss. Other than that, you need to have that tension member to hold it back so that it can behave as an equivalent coupler, correct? Other than that, what else is wrong? Okay, thank you. This part, no problem. What is this part? What's wrong with this? Not only that, but can you have a circular, can you model a circular member? Yes or no? Then how do you model it? Change this part, change the truss, this is the truss also. Very good. I can see that you all understand it better now. Very good. I think it's much, you all understand it much better now. I can see that. Hey, Dora, wait. I got still got a question. Yeah. No, the model, the design you must get it straight first, you know. If the design don't even get it, how are you going to model it? If the design is not stable, how are you going to model it? Look at this, one by one, you say here. This one first. What is the problem? This is yours, this one, okay. Okay, this one first, this and this is the same, so I just take 1%. You can go on. This and this is essentially the same, okay? But what's the problem with this? What's the problem with this? Bracing. What's the problem with the bracing?
Not fitting to the.
This is not going to be stable. Look at this. If you got a member like this, correct? Is it going to be stable? No. You need to have a member like this. Imagine if the hinge joint here cannot. It will just buckle over, correct? Okay. I hope you all understand what I'm trying to say. So don't try to take a class. When you do your truss model inside your assignment, right? Don't try to do something complicated. Take it as a normal bridge and do it. Why? Because it's just like a top cantilever. Doesn't matter. I will just do something like this, right? You know. That's it. This and this, right? You get what I mean? So, but then if you have something like this, let's say imagine you have something like this, will this be stable? Yeah. So this is not happening here. So that's why you need something like this in the middle, right? Okay. This is good, but same thing here. You need to be like this. Okay. Here restraint. That is good. So axial force, lateral force. Okay. Need a lateral force. Okay. Good. Who is this? Come. No, I got a question. I got a question. Who draw this? No, this is good, but my question, there is a problem here. This is good, but this is not a truss this is not a truss member. It's a beam member. This is very good because this is the first beam model that we see. Remember, you need to do a truss and a beam. What about the beam? How are you going to do it for the beam? This is one. Question. Remember, we say beam. All the beam member is a one-dimensional element. Yours is clearly not a one-dimensional element. Agree? So where can you draw it as a beam element? Who said that? Can you draw it as a beam element? This is very good. You remember all we have been doing is truss. What about your beam element? Have you think about it? What are you going to do for your beam? Can you all copy this down so you can use it as reference? Hey, don't erase that. Can you draw back the same one? Can you draw back the same one? Draw beside it. Yeah. Draw beside. Draw beside. Thank you. Draw beside it. No. Draw here lah. Because must be how many? Draw here. But you know what I mean as a beam, correct? Beam. This is a beam, one element. Remember when we said the cantilever beam? Okay, remember we said the cantilever beam, right? I can do a 3D cantilever beam, replace it as a single one-dimensional beam. Then I let you know what is the section area, what's the section profile. Correct? What about here? What are you trying to do here? Where is your beam element? Where is your beam element? Class, anybody know how it's going to represent this as a beam element? Anybody know?
Your side.
Which one? Anybody want to give it a try? This is important. Anyone want to give it a try? Can you see that? How can I represent this as a beam element? Do you all see that? How are you going to replace it as a beam element?
Your side.
Side?
Thickness.
Thickness. Do you want to try? Come. Quickly. Have. Correct. Yeah. But how to represent it as beam element? This is not going to be a beam. Do you all agree that this is not a beam element? Okay, but how to represent it as a beam element?
So must draw 3D.
No. It's okay. No. That's why it is. Okay. Can I do it like this? Represent this part as one element. Can I do that? Then I let this thickness, I let like the way that we prescribe inside the parameters. Tell me what is the thickness, what is the width, what is the thickness. Can I do that? This as one member. Can I do that? Can I do this part also?
Okay.
Can I do that? What about here?
Okay.
What about here? Can I do that? Do I need to do here? Can I do that? Can I do that? Does it make sense? Can you draw that?
Maybe we are drawing 6 beams in this case.
Yes, but what is 6 beam? What do you mean by 6 beam? That means it's a prop cantilever made up of 6 beam elements, but it's one prop cantilever. Just like like bridge, just now we were saying about bridge, right? I can represent it as one member, or I can represent it as a truss system. Correct? Yes. Can? Does it make sense? Class? Does this make sense? Why must this be a beam member? Can it be a truss member? Huh? Why cannot be a truss member? Anybody? Why is this different from this? Yeah. Yes. Why does it need to be an X? Huh? So anybody?
Is it because of pin joint?
Pin joint, exactly. What about pin joint?
The beam doesn't have a pin joint.
Louder?
The beam doesn't have a pin joint.
The beam doesn't have a pin joint. So what do you mean by it doesn't have a pin joint? Means that it can take rotational stiffness. Right? It has a bending stiffness. So when you bend here, when I have a prop cantilever like this, right? Then it will bend like this, correct? It will bend like something like this, Correct? It will bend something like this, right? Draw terrible, sorry. It bends like this. It will bend like this. It will bend like this. Correct? If it's a truss, if you bend like this, what will happen? It will just collapse over. Correct? So this must be a beam element. Agree? Okay?
Yeah.
So I'm not going to go into alternative beam model already. So I feel that most of you have an idea what's going on. Same thing for here, the truss element. Who is this group? Okay? Where is your restraint? The restraint will be where? Come, quickly. Do anybody else have any other questions for the first two modules, section 3 and section 4, the beam and truss model? Anybody else have any questions? Which constraint? Remember what we said just now, the constraint must be at the point. Okay, it must be a single point. Okay? if the class C, if my constraint is here, what is this? Okay. So that's why I say you don't need, you just do it. No. You extend it further. So I will extend here.
I have to help you to do the top border.
Here. Because it's a result. Yes, take from center to center, the result. Anybody got any question? Huh?